Under dynamic programming module, we'll be discussing the knapsack problem and memory functions here. So understanding the basic definition of knapsack problem. So it says that given n items, so n items are taken with weights. So each item has one weight, that is W1, W2 till Wn. And along with those weights, we also have values. So the value for W1, value or profit, okay, it is called either as profit or value. So for value, for W1 item, we have value as V1, and for W2, V2 till Vn respectively. So our aim is to fit these weights into a sack. Okay. So the sack has a capacity of W, capital W. So we have to fit these weights into the sack such that we should get maximum profit or maximum value. So this is what knapsack problem speaks of. Let's look what's written here. So given n items of known weights and values and knapsack capacity, find the most valuable subset of items that fit into a knapsack. Here all weights and knapsack capacity are positive integers, but item values need not be integers. Okay, we'll look into how to solve the knapsack problem using dynamic approach. If you have watched my previous videos, we have learned how to solve the knapsack problem using greedy approach. Here we'll be looking into dynamic approach. So firstly, we can divide all the subset of first I items that fit into knapsack capacity J into two categories. So we can differentiate it into two categories, the ones which fit into this and the ones which does not fit into this. So among subsets that do not include ith item, value of optimal subset is f of I minus 1 comma j. And among the ones that fit into the ith item, we can take j minus wi should be greater than equal to 0. Here j minus wi refers that if you are adding an item w, adding an item w1 into adding an item of wi into the sack, then from the total weight capacity, you should subtract the weight of this particular item, Wi, right? So that's what this it speaks of here. J is the capacity and Wi is the particular item which you're adding into the sack. Okay, so an optimal subset of I minus 1 items that fit into the knapsack of capacity J minus Wi. Yes, the value of such optimal subset is V of Vi plus F of I minus 1 comma J minus Wi. So here we derive a equation that is F of I comma J. In order to find the maximum weight, maximum profit, we can write it as max of F of I minus 1 comma J and F of I minus 1 comma J minus Wi plus V of I. This is in case J minus Wi is greater than equal to 0. This is the valid condition. Else we have F of I minus 1 comma J if it is less than 0. So our main goal is that F of n comma W, the maximum value of subset of n given items that fit into knapsack of capacity W and an optimal subset itself. So in order to understand this, let's look into questions. So we'll look into the problem. I'll try explaining and solving the problem in easiest way. Okay, so here we have weights are specified here, and then here we have the values, and then we have the knapsack capacity and the total number of items being specified here. Let me draw a table here comprising of items 1, 2, 3, 4. I have 4 items here, right? And let me write the values or W values, that is 2, 1, 3 and 2. Followed by that I have the V values, V or P profit. So it is 12, 10, 20 and 15. So now that I have constructed a table of the given question, let me actually let me construct the actual table here. This side it comprises of the capacity. So here the capacity is 5. So I should start from 0, 1, 2, 3, 4 and 5. And on this side I have the items. So it will be from 0, 1, 2, 3 and 4, because there are 4 items here, right? So I have constructed the table. So if there are no items, can I store any value in the capacity? Can I store any value in the sack? No. So I'll write it as 0, 0, 0, 0, 0 and 0. It goes the same. If the capacity value is 0, can I store any items here? No, it is not possible. Right. Done. Next, we'll move on to the next step. That is, we have capacity weight is this sack has the capacity to store 1 weight. Okay. And here first I have weight of 2. Can I store it here? No, it is not possible. So here I'll write 0 only. Next I have 2. Capacity weight is 2. And the weight here I have, the item weight is also 2. So when capacity weight and item weight are, when the item weight is greater, when the item weight is less than or equal to the capacity weight, in that condition I can store the values here. So I need to look into the maximum V or P value also. We'll look into that further. But as of this part, yes, weight 2 can be stored in capacity 2. So this corresponding profit of this weight should be written here. So profit of 2 is 12. So I'll write 12 here. So when I have 3 here, the capacity of the sack is 3, and here weight I have is 2. So weight of 2 and capacity is 3. That means I can store 2 value, right? So here weight of 2. So here I can write the profit here also, and for 4 also I can store weight of 2, and in 5 also I can store weight of 2. Yes, I'm done with the first item. First item is having weight of 2. I'm done with it. Next I'll move on to the second item. Second item has capacity, second item has weight of 1. So here weight of 1, that means I can store 10 here. Next coming to 2. So when it can store 2, the weight is 2. Here I have two options, either it can store weight of 1 or weight of 2. Weight of 1 has profit of 10, weight of 2 has profit of 12. So which one will I store? Out of these two I should select the maximum one, and the maximum one is 12, right? So I'll store 12 here. Next I have 3 here. So the sack capacity is 3 and weight here is 10. So here I have two options now. Either I can store 10 or I can store 2 plus 1. 2. Weight of 2 is 12 and weight of 1 is 10. So it is 22. Or I can store 10. Out of these two I should select the maximum one. So I can write 22 here. Next coming to 4. In 3 if I can store 22. In 4 also I can store 22. And in 5 also I can store 22. We have to understand that this is the maximum optimal profit which we can obtain at this particular instance. Okay, let's move on to the item 3. Item 3 has weight 3. So item 3 has weight 3. So can I store weight 3 in capacity 1? No, it is not possible. So let me write the previous values as it is. And for 2 also it is not possible. For 3 I have previously weight 22 and here I have 20. So out of these two I should select the maximum one. So I'll write 22 as it is. Now I have 4. So in 4 here I have options again. So either I can store 3 plus 1, or I can store 3 plus 1 is the possibility, right? So 3 plus 1 is 20 plus 10. So 20 plus 10 is 30. So 22 or 30, which one has the maximum value? 30 has the maximum value. So I'll write 30 here. Coming to 5. So 5 I have two options. Either I can write the previous value or I can add 3 plus 2. So if I add 3 plus 2 I get 20 plus 12, that is 32. I hope you have understood this step. Okay, moving on to the item 4. Item 4 has a weight 2. So it cannot be stored in capacity 1. So I'll write 10 as it is. And coming to capacity 2, it has two options now. Previously I had written 12 here, and the new profit here is 15. So out of these two I should select the maximum one. So 15 would be the new profit of capacity 2 at 4th item. Next I have 3 here. So 3 I can write previously 22 as it is, or I can write 2 plus 1. So 2 plus 1 value is 25 or 22. Which one has the maximum value? 25 has the maximum value. So I'll write 25 here. Coming to 4. I can write 30 previously, or I can write 3 plus 1. If I write 3 plus 1, I get 25 plus 10, that is 35. Now 30 or 35, which one can I write having the maximum value? 35 has the maximum value, right? So I'll write 35 here. Now I have 5 here. So having 5, the capacity is 5. So either I can write 32 previously as it is, or I can club 3 and 2. So if I club 3 and 2, what will I get? Weight of 3, that is 20, and weight of 2 is 15. Yes, if I club weight of 3 and 2, I'll get 20 plus 15, that is 35. This is one possibility. Next possibility I have is 2 plus 2 plus 1. So previous 2 value was 12, this 2 value is 15, and 1 value is 10. So if I add this, I get 25 plus 12, that is 37. So out of these two, which one, or 32 previously as it is. So out of these three, which one has the maximum value? 37 is the maximum value, right? So I can write 37 here. So 37 in the end cell, whichever value I get is the optimal solution. This is the optimal solution, or optimal profit which I can obtain. So in order to obtain the optimal profit, which are all the weights I have selected? So I have selected weight 1 I have selected, and I have selected weight 2, and I have selected weight 4. So this is the sequence of weights that I have selected. So if I write this all the weights W1, W2, W3 and W4, I can write 1, 2 and 4 are selected. 3 is not selected. I can represent it as 1 1 0 1. This is called as 0 1 sequence also. That is, whichever weight you are considering, put 1 there. Whichever weight you are not considering, put 0 there. That's it. So this was one question. Let's look into the next question. So here I have the weights, the profit or V value, W and 10. So let me straight away, let's write the items. So I have 1, 2, 3 and 4 items here, and the W values 7, 3, 4, 5. Let me write the V or profit values, that is 40, 2, 12, 40 and 25. And here the total capacity is 10 and number of items is 4. So this is a lengthier question. Okay, so capacity is 10. That is, I should start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 here. And on this side I have written the capacity, and on this side I should write the items. So let me write the items here. So it starts from 0, 1, 2, 3 and 4. There are 4 items, right? Yes. So when there are no items, no weights can be stored in the sack, right? And when the capacity is 0, it again implies that no weights can be stored, no items can be stored into the sack. Okay, next, moving on to the first item, I have weight as 7. So can weight 7 be stored in weight 0? Weight 1? No. In weight 2? No. In weight 3? No. 4? No. 5? No. 6? Not possible. At 7 I can store 42. So weight 7 having the profit of 42 should be written here, like how we did in the previous question. Now weight is 8. I have 7. So 7 can be stored in capacity of 8, right? So again I'll write 42 here. It implies the same for 9 and 10 as well. Now I'll look into the item 2. Item 1 is done. Item 2 having weight of 3. Weight of 3 is there and capacity is 1. I cannot store. 2 I cannot store. 3 I have 12. So I can store it here. And if in 3 I can store, in 4 also I can store it, right? So I can write 12 here. In 5 also I can store. In 6 also I can store. In 7 I'll have 42. In 8 I'll have 42. In 9 42. In 10 also 42. Now I'm done with these two. Okay. Okay. So in 10 I can write 7 plus 3. That is 42 plus 12. That is 54. 54 can be written here. That is the possible combination having maximum profit, right? 54 can be stored. Coming to item 3. Item 3 has weight 4. So for weight 1 0, weight 2 0, weight 3 12 as it is, and weight 4 it is 40. Previously I had 12 and here weight 4 is 40. 12 or 40? 40 has the highest capacity. So I'll profit. So I'll write 40 here. Now for 5. For 5 I have 12 or 40. So I can write 40 only here. For 6 also 40 only I can write. For 7 it could be 7 also I have option here. For 7 I can write it as 4 plus 3. 4 plus 3, how much will I get? 40 plus 12, that is 52. So I can write 42 or 52. So I'll write 52 here. 8. For 8 also I can write 52. For 9 also I can write 52. And for 10, 52 or 54, 54 has the higher value, higher profit. So I'll write 54 here. Coming to item 4. Item 4 has the weight of 5. So can it be stored in 1? No. 2? No. 3? No. 4? No. And for 5, it is 25. The profit is 25, but previously I had 40 here. So I can write 40 only here. Next, coming to 6. 6 also 40 only I can write. Coming to 7. 7 I can write. So in 7, again, do I have any combination possible here? No, it is not possible. For 8, is any combination possible? 25 plus 12. 25 plus 12. 37. But here 52 is there. So 52 has higher value. So I'll write 52 only. For 9. For 9 I have combination. I can write combination of 4 plus 5. How much will it be? 40 plus 25. 5. 65. I have 65 here. One possible combination. Subset combination. Or here I have 52. 65 or 52. 65 has the greater value, right? So I'll write 65 here. Coming to 10. For 10, do I have any possible combination? 5 plus... No, there's no possible combination. For 9 it is 65. Then for 10 also I can store 65 profit. Right. So this cell here represents the optimal solution from all the feasible, from all the possible solutions. The solution or profit. So I can say that in order to get 65, I have selected item 3, W3 and W4 are selected. This is the sequence. Let me write the 0, 1 representation. I'll write W1, W2, W3, W4. Did I select W1? No, I didn't select W1, so I'll write 0. Did I select W2? No. Did I select W3? W4? Yes. So this is 0, 1 sequence. So now that we have looked into two problems about the knapsack problem, let's further look into the memory functions. What is memory functions? So what are memory functions and why is it important? So practice of sorting the results of expensive function calls and reusing those function calls when same input occurs again. So this is what memory function says. So instead of using the same functions again and again, so it says we can avoid the need to recompute the result, which can improve the efficiency of an algorithm. So memory functions aim to improve the efficiency algorithm by avoiding the recomputation of results again and again. The same result, you are repeating it again and again. So don't do that. Directly write the value is what this memory function states. So using dynamic approach, we solve knapsack problem in bottom-up approach. Yes, we have solved it in bottom-up approach. So it goes on filling solutions to the sub-problems, right? At times, these calculations are not necessary. To solve this redundancy, we make use of memory functions. Yeah. So it makes use of top-down approach. So same table is used. Initially, all entries are marked null, indicating that the values are not calculated. So while calculating, the entries are checked. Those which are not null, it simply retrieves from the table, else it computes using recursive call and result is entered into the table. So this was about the knapsack introduction, the memory functions using knapsack. Let's quickly look into the algorithm part now. So here I have the algorithm written here. So we have to implement the memory function method for this knapsack problem. So here input I'm taking a non-negative integer I indicating the number of items and W that is J indicating the knapsack capacity. So the output which I have to obtain is the optimal feasible subset of first I items. Yeah, that's that we know, right? So starting from the algorithm, if f of I, so here I have written mf knapsack I comma j. I is the number of items being considered and j is the capacity of the knapsack. So here moving on to the algorithm part, f of I comma j is less than 0. That is subset, the sub problem computed not yet. So we have not found the value yet. It is null. That's what it's saying. Okay, sorry, it's not null. It is less than 0. So we actually mark it as -1 here. We look into the problem. Yeah. So if j is less than weight of I, that is item weight more than capacity remaining excluded. So if this is satisfied, a value would be equal to mf knapsack I minus 1 comma j. So iteratively we are repeating this again. So we are solving the sub problem excluding the current item. Okay. Else we will find the maximum value. So we'll consider both excluding and including the current item. So mf knapsack I minus 1 comma j, value of I plus mf knapsack I minus 1 comma j minus weight of I. So finding the value here will update it to the f of I comma j, that is store the computed value in the table to avoid recomputation. Once the values are updated, we need not calculate it again. So unless we encounter these two situations again where we have to select the maximum value, there it could change. So finally we are returning f of I comma j, that is return value of optimal solution. We'll look into a problem now. So yeah, here we have the problem, the first problem which we had solved, this one. So initially what they are telling is to take -1 everywhere. So we have taken -1 everywhere. Yes. After that, we should start filling the values. So 1 cannot be stored here, but weight 1 can be stored in capacity 2 because item 1 has 1, 2, 3, 4 items. So item 1 has the weight of 2. So 2 could be stored, 12, 12, 12, 12. I've written done. Now for 2, coming to 2, so item 1 I'm done. Item 2 I'll go. So for item 2 I have the weight as 1. So here 1 can be stored here, but they have put null here because let me explain the logic here. So if for 2 comma 1 if I write maximum value is 0 comma 10, that is either it could be 10 or it could be 0. So the maximum is 10. Now I'll take j is equal to 2. That is I'll compare including and excluding the item 2. So if I exclude the item 2, I'll get 12, and if I include the weight 1, I would get 10. So out of 10 and 12, 12 is greater. So I can exclude this part and fill it here because this is not necessary. I have found the maximum value here, right? So I'll fill it here. So that's what I hope you have understood this logic. Yeah. So coming to 2 comma 3. So if I look into the third item, it could be, I can write it as 2 plus 1. So 2 plus 1 profit is 10 plus 12, that is 22. So of course the value is greater, so I should write this mentioning is required here. So I'll write 22 here. Coming to 4. So in case of 4, I can write 2 plus 1, that is 10. 2 plus 1 is 4 is not possible, right? So I should write the previous value only. Instead of writing the previous value only, let me put it null here because it's not required, right? So next, coming to 5. Again 5, I can write the maximum value here, it is 12. And for capacity 3, if I can store 22, then for capacity 5 I can surely store 22. So I have written 22 here. Coming to 3, so 0 and all these are null because it's not required. Here again the same logic implies it's not required here. So if I take j is equal to 3 comma 2, so if I explain for j is equal to 3 comma 2, if I exclude it, I'll get 12 here. And if I include value of 2 plus f of 1 comma 2, that is I'll get 22. So here I can write 22 here. Okay, so coming to j is equal to 4, so if I exclude it, so 22 I'll get, and here also it's not necessary, so I'll leave it empty. And here 32 because capacity 3, item 3 has weight of 3, and out of these I can compute 2 plus 1. I can compute for 5, no, I can compute 3 plus 2. If I compute 3 plus 2, it is 20 plus 12, that is 32. So this is required. This I am obtaining the maximum value. Instead of comparing the previous one, I am obtaining the maximum value, right? So I'll include it here. Coming to the 4th row, so j is equal to 1 and j is equal to 2 items can't fit because weight 2 is greater than the capacity. Yeah, so I can carry forward the previous values itself, that is null here. And coming to j is equal to 3, here I should compare, I should exclude and include the item 4. So if I exclude the item 4, I get 22, and if I include the item 4, I get 25. So again, it's not necessary here. It is because I have the higher value here, so I can put null here, that is empty, and here also it is empty. Coming to 4 comma 5. So if I look at this, I can write it as value of 4, that is 15, plus value of 1 and value of item 4, item 2, item 1. If I club these, I can get 37, right? So here, so this is what the optimal solution which I have obtained. So top-down approaches, like here they have explained it here. So you can key insights. You can say the memorization, that is the memory function method uses memorization to avoid redundant computations. Yes, this is true. Then we have the recursive solution. The algorithm operates recursively, breaking down the problem into sub-problems and building the solutions upon previously computed values. Yeah, we know this. And here there is, although the memory function has the same time complexity as the bottom-up dynamic programming approach, it is order of n into w, it reduces unnecessary computations for the problems with many overlapping conditions. So we can say that because of these insights, memory function has an upper hand over the normal knapsack problem. So I hope you have understood the memory function and knapsack topic. If you have any doubts, do let me know in the comments and subscribe to my channel. Thank you.